Hello, welcome back. Um, yeah, so I'm back. I don't know if you guys were watching earlier, but I was streaming earlier, and I just had to leave for a little while. Had to go do something important that I wasn't expecting to have to do, so I wouldn't have started streaming if I knew I'd had to interrupt it at some stage. But we're back. It was just as we had finished part one of day 9 that I had to go. Let me turn down the music a little bit. Yeah, so it was just as we finished part 1 of day 9, which was nice. So you can see we got the right answer. we're 1 gold star closer to restoring snow operations. We can continue now to part 2. So if you recall, because obviously it'll be useful to go through the puzzle again, maybe, because we'll be using the same inputs. What we have is a list of sequences, and what we need to do is find the next item in the sequence. And now they are all they're all polynomial sequences. There we go. That's what I wanted to figure out. They're all polynomials. And actually, I think that's something I hadn't quite fully put together there a minute ago. But yeah, this is a polynomial sequence. All of these are polynomial sequences because they have, at some point, a common difference. So that's what we were trying to find as the next item in the list, or in the sequence, I should say, by just finding the difference. So we're, for this first example, we realized the difference between all of these is 3. So we know that the next one is 3. For the next one, though, if we go back down to here, for the next one, you can see the difference is, the first difference isn't constant. Yeah, exactly. I just kind of realized that. Exactly. So the number of steps. So in other words, the depth of this graph is basically the degree of the polynomial. So this is just linear, degree 1. This one here is quadratic. That makes sense? I think it makes sense. And so on. But I rather have a feeling now that we might need to use that information for solving part 2, which I haven't read yet. So let's do that. But yes, so what we have done is we've written a recursive function. If I go back to the code, we've written a recursive function that just gets us the basically the difference between the number that we're looking for. So it goes down to the bottom until we have a row of zeros, and then it goes back up and fills in these gaps. And so we get our next digit, which is what we want. So we got our answer. So that's interesting. Okay, so of course it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling in the next values of each previous sequence, you should instead add a 0 to the beginning of your sequence of zeros and fill in new first values for each previous sequence. In particular, here's what the third example history would look like, or looks like when extrapolating back in time. Okay. Adding the new values onto the left side of each sequence from bottom to top eventually reveals the new leftmost history value is 5. Doing this for the remaining example data above results in previous values of -3 for the first history and 0 for the second history. Adding all of the 3 values new together produces 2. So analyze your Oasis report again, this time extrapolating the previous value for each history. What is the sum? Okay, I don't think this should be too difficult. I think I should be able to just change my my function here, because what we're doing here is we're adding this onto the end of the list. And all I want to do now is just, well, do the opposite. We want to figure out that we want to put it at the start of the list and subtract. Oh no, sorry, this is wrong. Sorry, this is finding the differences. Sorry. So it's this part that I need to change. Am I thinking about this correctly? So let me think for a minute. So once we get to 0, I still want to return 0, so that's still correct. But then what I want to do, so I think potentially it's just this that's changed, and well, this as well. So this is now not next diff, but rather previous diff. And then what I'm going to return, it's not, I'm doing diffs, so the last one plus the next one. I was returning the last plus So let's say I had 2. I was doing 2 plus 0, give me 2, and then I do 6 plus 2. So now I want to do the opposite. 2 plus 0, or 2 minus 0, I think it is, right? 0 minus 2, 3. Yeah, so I now want to do first one minus the previous difference. First one. So this minus the previous difference. Have I got that right? We'll find out soon enough. Well, that feels right. And then we do the same thing down here. So we read the sequence diff. So previous value is again going to be 0 minus the diff. Get that in. Previous value. Let's just try that out with our test again. We should get value 2, I think, or the number 2. Well, that worked. I'm scared to do this, because that seemed a bit too easy. But we get 971. We'll find out quickly enough if that's correct. Okay, that's nice. Okay, well, I'm glad that worked out. So I think I would have looked like an idiot if it didn't. But yeah, so the way we did our code earlier just made it very easy to just change it around. So instead of getting the next one, we just get the previous one and add it into the start. Or well, we're no longer handling lists here, really. We're just returning the individual element. So slightly easier even. We don't have to insert anything, which potentially could have been costly. But this is fairly straightforward, I think. Okay. Well, that was nice. So let's go back to our calendar, because I suspect, yeah, there we go. So that's our oasis that we've just... Yeah, it's quite fun. I find it, so it's what I like about these challenges, is that they're nothing, they're not groundbreaking. They're all kind of very, I suppose, solved problems in computer science. They're interview questions for a reason. And people use these kind of questions, or even these exact questions for interviews, because they're a good test of someone's coding ability, I suppose. So it's not about, deriving some new concept in mathematics. It's not about figuring out a brand new algorithm. It's about kind of figuring out what it is you need to do, and well, just executing that in whatever language you're using. But yeah, tabulating polynomials. I didn't know that phrase, so we'll go with it. Enjoy that one. I think that was a nice one. I would say that's on the of all the ones I've done so far, that's probably on the harder end of things. Not 9b. I think 9b was fairly easy, but 9a was kind of, I suppose 9 as a whole was, I would say, relatively hard compared to some of the previous ones. There's been some tough ones, and there's been some fairly easy ones. And so I think 9 is probably towards the... I don't think... It's definitely not the hardest, but it's up there with some of the harder ones. But we're making good progress, I think. So, day 9. Considering that I only started this, I think... on... Well, what day is today? I think I started this on Monday. With day 1. And there was a couple of days where I didn't really do anything at all. So, I think it's good progress trying to catch up. Even if I do catch up, I won't be able to keep up doing it every single day. I'll be going away for a few days next week, so I'll have to, even if I do make it up to, let's say, 16 or 17 the next few days, I'm not going to be able to do it every day. But anyway, that's fine. I'm a bit scared now to start day 10. I almost kind of want a little bit of a break, but no, we just got back. We just got started, so let's keep going, I think. I'm gonna take some water though. Okay. It looked like the raid worked earlier as well. We were able to raid Trucker Dylan, and I got a shout out apparently in his stream. My Twitch was apparently also set up to say that I was playing Microsoft Flight Simulator. So Trucker Dylan did mention that when he got the notification that we had raided his stream. But of course we weren't playing Microsoft Flight Simulator, were we? But it doesn't matter. I fixed that now. I think it just says software development or something like that. I couldn't find one that was just like coding. It's not really doing software development. It's not really. It doesn't feel quite honest. But anyway, it's the closest I could find. So, day 10, pipe maze. Oh dear. You use the hang glider to ride the hot air from Desert Island all the way up to the floating metal island. So we have moved on to a new island now, day 10. This island is surprisingly cold and there definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find signposts labelled Hot Springs. And the very helpful, presumably, yes, a Wikipedia link to, in case you don't know what a hot spring is. There we go, very useful. I really don't know why some of these... Anyway, whatever. Maybe there's a reason, maybe... it doesn't matter. Anyway. Hot springs pointing in a seemingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape here is alien. Even the flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It didn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing on is densely packed with pipes. It was hard to tell at first because they're all same metallic silver color as the ground. You make a quick sketch of all of the surface pipes you can see, your puzzle input. The pipes are arranged in a two-dimensional grid of tiles. So, pipe symbol is a vertical pipe connecting north and south. Hyphen is a horizontal pipe connecting east and west. L is a 90-degree bend connecting north and east. Yeah, J connecting north and west. 7 connecting south and west. And F connecting south and east. A full stop is ground. There is no pipe in this tile. S is the starting position of the animal. There is a pipe on this tile, but your sketch doesn't show what shape the pipe has. Interesting. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal is one large continuous loop. For example, here is a square loop of pipe. If the animal had entered this loop in the northwest corner, the sketch would instead look like this. Right, and we don't know... In theory, we don't know what this pipe is, but because we know that it's in a one large continuous loop, then we can kind of figure out that it has to be this this F pipe. In the above diagram, the S tile is still an F bend. You can tell because of how the adjacent pipes connect to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Pipes those pipes connect to... Right, let me read that again, I'm not paying attention. In the above diagram, you can still figure out which pipes form the main loop. They're the ones connected to S. Pipes those pipes connect to, pipes those pipes connect to, and so on. Every pipe in the main loop connects its two neighbors. Every pipe in the main loop contains its connects its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to these two pipes. To those two pipes. So here's a sketch that contains a slightly more complex main loop. Let's see if we can figure it out. So here's S. We know it connects to two pipes. They are obviously J here and the pipes and this vertical one. It goes like this, like this, like this, like this, like this, like this, and so on. There we go. So it literally goes around the whole thing. Here's the same example sketch with the extra non-main loop pipe tiles also shown. Same example sketch for the extra non-main. Okay. So this one's slightly more annoying because there's some that may be... Okay. So if you want to get out ahead of the animal, you should find the tile in the loop that is farthest from the starting position. Because the animal is in the pipe, it doesn't make sense to measure this by direct distance. Instead, you need to find the tile that would take the longest number of steps along the loop to reach from the starting position, regardless of which way around the loop the animal went. In the first example with the square loop, I would imagine it would be J. 1, 2, 3, 4, 1, 2, 3, yeah. You can count the distance on each tile loop like this, yeah. Farthest point from the start is 4 steps away. Here's the more complex loop again. Apparently it's that one, okay. So find the single giant loop starting at S. How many steps along the loop does it take to get from the starting position to the point farthest from the starting position? Okay. Okay. So I suppose it's, in a way, it's a pathfinding problem. But it isn't really, because once we find S, which I have somehow spotted amongst all of that, I imagine it's the only S as well. Yep. Somehow spotted it there. Once we find S, obviously we need to look at the four tiles around it to make sure we find the 2 pipes that connect to it. Although actually we only need to find 1. Yeah, exactly. So that's what I'm thinking. There is no actual pathfinding. It seems like a pathfinding problem, but there isn't actually, because it's once you find S, you find one of the pipes that connects to it, and then you're just following the directions. So I would go down and I'd find this, and now I know I need to go right. Now I know I need to go down. But I suppose if I find a J, I need to be aware of what way I came, what way I approached it. That's important, because the J we could be going down or we could be going left. So we need to know which way we came. So we came from the left. That means we then end up going down. No, sorry, not down. Sorry, I got that wrong. Up, and so on. So that's that. So obviously we need to be able to follow those instructions. That doesn't seem all that hard. And then we need to find the one that's furthest away. Now we don't know how long the loop is, so potentially we need to actually get all the way back to S. I think that's something that we're gonna have to do regardless. And we obviously keep track of how long it took us, how many steps it took. And then, obviously, once we know how many steps it could, we could just continue following. We could just start again until we get to the midpoint. But I think it'll be more useful if we maybe save... well, I don't know. I suppose it depends. So what I was thinking is, instead of traversing it again until we get to the midpoint, I was thinking we could save all of the pipes into a list with that, with this distance thing. And then now obviously it won't actually be 3, it'll be 5 and 6 and 7. And then, but that doesn't matter. We then just need to find the one that's at position 4. So that's better in terms of time in theory, because then once we know how long the thing is, we can just look up that specific one in the list. It's just an array access or list access, but it also potentially means storing quite a large number of coordinates. Let's say. I'm sorry. What do we need to store? Or what's the answer? How many steps? Oh, we don't even need that. Sorry, how many steps along the loop does it take to get from the starting position to the point farthest? So we don't even need that. So it's just the length. Once we get back to S, we divide that by 2. That's it, no? So if this is S, we go 1, 2, 3, 4, 5, 6, 7, 8. And we just divide by 2. Oh god, we don't even need to do that. Okay, I think I can start coding. I think I know what I'm doing. I'm sure I'll make many mistakes along the way, but I think I know where to go. So let's let's start a new. Let's just create a new folder. It'll be easy. Folder. Day 10. We're in the double digits. I don't like how Sublime puts that at the top, beside the 1, because it orders it. Well, whatever. It doesn't matter. And let's create a new file. This is going to be. Let's save this. 10a. And let's also create an input. Let's use our test ones just to start off with. Yeah, I'm not bothered to change that now, but yeah, that's a good idea. Okay. So I'm thinking, what should we start off with as our kind of basic? I like that solution. Base 26 numbering. Sure, we'll do that. Okay, so. I suppose we'll start off with we'll start off with a very simple one. I don't want to sort of, you know, we can build up, but this will be our kind of test input. Don't need this anymore. Okay, so I think first thing I'd like to do is write a function that, given the current pipe and the direction that we came from, will tell us where we need to go next. Making that function look pretty might be a little bit interesting, but you know, otherwise it's a fairly easy function to write. I'm curious if there's a way to make it nice. So where to next? Well, I suppose, and what I also need to think of, because there's obviously 4 possible directions. We can either go south, east, west, north. How do I want to do that? Will I just do that with just, you know, the letters NESW? I think that might be okay. Yeah, I think we'll do that. So, where to next? I don't know. Is that a good name for this function? I'm not sure. So what do I want? I want the current pipe, and I want the from. So where we came from. From is some kind of from. I don't know, something like that. I'm not very good at variable naming or function naming, clearly. Okay. So let me think. Let me write some stuff down here that I'll get rid of later. So we have, there's not that many possibilities, right? So we have, these are all of our possibilities. Let me go back to this, like so. Okay. So, vertical pipe. If we came from the north, it needs to give us south. Let's go for colon here. And if we came from the south, we need to go north. Oh no, north. If I have a hyphen, if we came from the east, we need to go west. Came from the west, we need to go east. So actually, one way we could store these is we could have basically a dictionary with all of these symbols and then the pairs of directions they connect. So that instead of having to write a very, very long if a very long function with an if for each single case, I'm just looking up in the dictionary which directions it connects, and we know the direction it came from, so it's, you know, the one that it isn't. That makes sense. But it'll still be used. Well, I suppose let's write it out then. Let's write this dictionary. So this is our connections, let's call it. And if I remember correctly, dictionaries work like this. And I want to say that I'm not actually sure if there's a difference in Python between single quotes and double quotes, but I'll keep using single quotes for characters and double quotes for strings until someone tells me otherwise. So this is gonna be, there is no difference. Okay, well then I'll go for double quotes because it looks nicer, I think. Great, thank you. This is gonna be connecting north and south and south. So, is this correct syntax for dictionaries? I can't remember. Python dictionary. Yeah, and then just a comma. Okay, great. Need this anymore? There we go. Okay. We then have our hyphen or horizontal pipe. This connect east and west. We have our L connects north and east. Our J connects north and west, is it? Yep. North, west. Well, good question. So I suppose what the point of this is that in my where to next function, what I'll do is when I get the current character, I find the tuple corresponding to that or tuple. I keep saying tuple. Someone corrected me the other day and said I should be saying tuple. I get the tuple corresponding to that pipe, and then I obviously the where to next is going to be the item in the tuple that isn't the one in our from. Maybe there's a better way of doing it. See, I say quintuple. Is that incorrect? So maybe it is tuple. I don't know. I'm sure both pronunciations are okay. I've always said tuple, and someone said the other day that they thought it was tuple. Yes, that is a very good point, isn't it? Because it's always going to be... right, so I can just go like this. This is why it's great to have people watching along and telling me where I'm doing something that's really not very smart. But yes, good point, thank you. J was north and west. 7 is... south and west. I'm gonna read the thing on the right rather than trying to figure out by looking at it. F is south and east. Nope, comma. Now we should never actually land. If we've landed on a full stop, something's gone wrong, right? We should never land on a full stop. That means we made a mistake. So I don't think I need to put that in. And then S is our starting position, so I don't need that in either. Okay, so I think this is actually all we need, so we don't need that. Okay. So now, where to next? Well, we get so our options, let's call them opts, is going to be connections at current. So find the I'll get this straight back. And so then what I want to say is let's just check it. So if opts 0 is equal to our from direction, then we return opts 1. And otherwise we return opts 0. Oops. There we go. So I think that's that function. So let's test this out just to see if it works. So print where to next. Let's say we are at a pipe and we came from the north. We should get south as the answer. And we do. let's say we come from a hyphen. Okay, I suppose I should do this. So obviously we might want to ask the question. Okay, well, what happens if I put a hyphen and I come from the north? Well, that shouldn't be possible. Again, that means we've done something wrong somewhere. So I may want to print out an error if that happens. So I might just change this just so that I can do that. So I know I don't necessarily need to, because if I've done everything else correctly, we should never reach this situation. But I just want to test it out. So if ops1 is from there, then return 0. Otherwise, let's just return. Well, we can actually just, it's a string that this returns, so we can actually just return error. There we go. So this should give us an error. There we go. However, if I do east, this should give us west. If I do west, this should give us east. Okay, I'm fairly confident this is working. As long as I've written these correctly, there shouldn't be a problem there. So what's next then? Yeah, I could, but I'll just leave it as a. I don't. Again, this shouldn't happen. This will only actually. Okay, no, you know what? You're right. The whole point of me doing this is for me to learn Python. So you're right. I should use the raise keyword because I don't know how to use the raise keyword, and that means I need to learn how to raise an exception or an error. So how do I raise my own errors? Raise. Why is it racing the function itself? I'm not sure I understood that. I should probably read through this rather than That's the first example of race. Okay, can I just write will this give me an error? Like racing this, will this give me an error? If I do, let's say this. Hang on, actually. I suppose it works. I'm not sure if that's correct syntax, but I guess it works in that it did give me an error. But I'm not sure if that's... Yeah, it's not... I haven't done what I actually meant to do. So how do I use race then? Oh, I can just say race. Is that all I need to do? No active exception. Okay. There we go. Racing exception. Okay, so I can just say, fine, value error, for example. Let's raise that. It doesn't matter, I suppose. Yeah. Do I need a... Nonsense. Likes. This still doesn't look correct. Well, I'm still getting an error for the race. So this isn't working, is it? That worked? Okay. Yeah, okay. That's fine. Cool. Just to check this is still working. Yeah, okay. So then my next step is I just need to find S. Now I could be quite cheeky because in Python I can just use the find function. So let's do that. So let's load in our file. So our base, let's call it, is going to be open. Let's start with our test data. And then our start is gonna be maze.find. We're finding the letter S. And let's just maybe... what should we print out to check if that's correct? Well, it'll work. Well, let's print out the value of start. It'll be the index. There's not an easy way to do that. Index. No, sorry. Maze dot was it read string or read lines? Read lines gives me the lines. Sorry, what was the way to what was the way to see, the thing is, I actually want to, even if I find the index of S, I want it in sort of coordinates, don't I? So let's not do it this way. Let's be a little bit smarter about this. Are you familiar with statements in Python? No. There we go. Is this something that would help me in this scenario? But anyway, what I'll do in the meantime is I'm gonna do so for y, isn't it? For y line in enumerate base, and then I can say for x and car in enumerate line. So now if car is S, then let's just print out x and y. See if this works. 1 1. Great, that didn't work. Oh no, sorry, that did work because sorry, I forgot I was using my test. 1 1. Yes, that did work. Okay, so now that we've found S, I suppose what I want to do I still want, you know what, sorry, this is I'm still gonna go read lines. Sorry, read lines. And the reason for this is that I can then go, so I can go like this then afterwards. I can go x, I can go x, y. So for example, let me comment this out for a second. I could print out maze at 1 1. This should print S. Yeah. And if I do, just to test that I've got X and Y the right way around, this would be 0 1 2 and 1. Yeah, so these are the wrong way around, so it's YX. So 1 2. It appears that I don't know if it's just on my end, but I can't. I think the link got blocked there. I'll just look up. So Python with statement. Oh my god! I should stop clicking on these Geeks for Geeks articles. Ah, I see. Okay. I suppose in this case, and do correct me, but given that I'm not writing to any file and I'm only reading it, is there any benefit to be using with here rather than having to close it when I'm done? I'll leave that up. Anyway. Okay. So, what do I want to do? So, now that this finds S. This here finds S. There you go. Yeah, okay, that's a fair point. So let's do that then. So with open as base, right? That's what I want to do. So with open test as base. This would work then. But can I do the read lines here? Can I still do with open dot read lines, or will this give me some kind of error? Well, I suppose let's find out, will we? So obviously this doesn't work, rather. Sorry. Okay, that seemed to work. Yeah, good point, thank you. Okay. Okay, I have found S. Sorry, so this was all to do with, so my my start is well, we call our start as well, we call it current because we're going to be using it later anyway. Current is let's just make it like an empty. That makes sense. And then I can just say current equals no, see, I don't actually. Do you know what I'm gonna do? No, I'm not gonna do. Sorry, just had an interruption there. Had to mute myself for a second. Okay, what was I doing? I was trying to save the x and y into a reasonable. Let's just do. You know what? Let's say. No, I still want to save it in some. So I'm just trying to think what's the best place to save this. I will just, you know what? I will use it. A tuple, whatever it is. Current is equal to x and y. Now we need to remember then we need to reverse it, but that's fine. Let's just, again, just check that this is working. Print, current. Yeah. Okay. So, next step. Next step. So now that we have found S, what we want to do is we want to start at S, and we want to follow the directions. I'm going to do this in a do-while loop. And I've never done a do-while loop, so let's see. I assume it's very simple. I assume it's do. Oh, maybe not. Sorry, I've never done a do-while in Python. Is what I meant to say. How do we do? I want to do. Oh God. Interesting. Yeah, well, I suspected. Okay. Because what I want to do here. Okay, so it's okay. Okay, that's fine. I can do it that way. So while true then. And then what we do is if maze at current 1 current 0 if this is equal to S. Nope, sorry, this is equal to S, and then we break. Let's just print done, and I'm just gonna leave it like that. I just want to make sure that this loop is working. So they should just print done pretty much straight away. No, I didn't like that. Right, so that's because Maze is a file again. So this is why I wanted to do... Okay, well then what I'll do is I'm going to say as file, and then Maze is going to be file.readlines. Yeah, there we go. Done. Okay. And let's maybe print it. So we obviously want our steps as well. So steps is going to be, let's say, 0. And every time we do this loop, steps plus equals 1. And let's maybe print out the steps instead. Just want to test this. Should be printing out. No, sorry. Not in quotation marks. It should print out 1. Okay, we don't need this anymore. Okay. So now comes the fun part. Not that fun. But what we now want to do is we want to find out where we're going next. So we start off at the start. We start at S, and we need to go somewhere. So next is next direction is going to be where to next with let's just do current pause, and my current height, let's say, let's just call it current, is going to be equal to this. Just to make it a little bit clearer, at current pause at 1, current pause at 0. And so then we're going to pass in our current one and the direction we came from. Oh, actually, on our first run, we actually need to... So once we find S, the first thing we need to figure out is which... is where to go. So from S, it's actually slightly different because we need to find a direction that works. Sorry, S was near the top. Where is it there? So we go to S. We actually need to figure out which one of these we can use to keep going. So... Okay, so how shall we do that best? So I suppose we can actually use our we can actually use our where to next function. So basically we get the so what I'm thinking of just making some space to work with. What I'm thinking of we can do is so we know that our current, let's still use our if okay, we still need this at the top. Now we no longer need to say this. But we're going to check this again at the top. Because if our current one is S, then what we first need to do is figure out where to go. So actually we could do the CC. So if current is S and actually we can just do it like this. If steps is equal to 0. There we go. So if steps is equal to 0, then what I want to try and do is I want to try and figure out... sorry, what I'm going to do is I'm going to call the where to next with the ones around it, around the starting point. So we're going to call where to next... and we're going to have to put a few tries. Yeah, good point. All right. Thank you. I can see now why this width thing is quite useful. Okay. What I'm thinking of doing is I'm going to call the where to next 4 times, or not necessarily 4 times, but until we don't get an exception, basically. So we're probably going to get 2 exceptions. If we don't, then great, that's our starting point. So what do we do then? So we're going to call where to next with but instead of this, it'll be, so we'll do +1. And so then if we're doing +1, then we're coming from, why is this giving me an error? What it was. What didn't it like about that? Did I miss something? Hang on. Yeah, I did. Okay. So if we came from the east, sorry, if we came from the west, then we're going east, right? So this would be correct. That makes sense. So we're going, no, sorry, this is the Y. Very important. Sorry, that's the Y. This is the X. So this is +1. So if we're adding to the X, we're going east. We came from the west. So that's correct. We also want to do -1, and that means we've come from the east. And then we want to do +1 here and -1 here. So if we did +1 on the Y, that means we're going south. We came from the north. Okay, like so. Now some of these are going to give me exceptions. Do I maybe want to do this outside of the while? I maybe want to do this outside of the while. Just find the first pipe connected to S. And just do that. And then we'll start off with step set to 1 instead of step set to 0. I think that'll be smarter than doing this in the while, because we only need to do this once. So yeah, let's do that. So oh god, okay. So steps is going to be equal to 1 then when we eventually get to it. So okay, so how do I want to structure this without making it look so ugly? So okay, I also don't remember how to do it. Try except, well, actually I think it is just that, isn't it? So try this except value error, right? So that's what we're erasing. And we don't actually do anything in the except if we don't care about it. Basically, we move on to the next one. However, if it is actually, we can make a chain. Okay, so if this doesn't work, we try the next one. This is ugly, I'll admit, but it'll work. Except, I think this works, right? We can do it this way. We're obviously not doing we're missing one part here still, but that's fine. Then we try the next one. Except value error. Finally try, well, I mean, to be fair, if the last 3, actually, if we find 2 that aren't, we know the other 2 are. So we don't even, we should probably, again, for safety, we probably should still do it. But if west and east were wrong, that's fine. I don't think I will have an empty block. But okay, that's good to know. So my point being that if it wasn't the one at the east and it wasn't the one at the west, well then both north and south are going to be correct. So it doesn't matter which one we start with. So that's fine. Okay. And so finally what I'm going to do is I'm going to put the actual loop then for following the path. I'm going to put that in a function here. So follow follow path. And all I need to know is my starting position and my starting what do I need? My starting position and the direction I came from. So start and from direction. And so what this is going to be is we're going to set our steps equal to 1. Well, it's basically going to be this. So let's copy this. It's very ugly right now. I know my code is very ugly. I will fix it. So we start off with steps equal to 1. Now we can actually do it properly. So now we can say current is maze at start. And so now we can say while current is not equal to s, and so I don't need this anymore. And don't need this. While current is not equal to s, so we obviously move one step. So next direction is going to be where to next with current, and the direction we came from, which is going to be from direction initially. But obviously we need to update this then. I'm gonna write another function, which is just gonna give me the opposite direction. Opposite of a direction. And we're gonna do it like this. No, we won't make a function. We'll just make the dictionary. There you go. So n is gonna, but this is gonna be opposites. Opposite. Is there a nicer way? Maybe. Probably. And in theory, I don't need to repeat this, but it'll be easier. So then our from direction is then going to be the opposite, our next direction. Opposite next direction. And then finally what I need to do is actually move, right, based on the direction. So can I do this in any particular nice way? Because I can add tuples together, right? Python tuples, I can add them. Or am I stupid? This is not very useful again. Tuple, tuple, whatever it is. So. I know that, yeah, so it did say that tuples are immutable, but what I want to know is if I can add two together. Because what I'm wondering is if I can do... if I can do something like... I can just test it out, can't I? So if I could do something like this. And I might just make a new file here very quick. File, new file. And this is going to be, let's say this is test.py. So, no, add is equal to, let's say, 1, 3 plus minus 1, 0. And then print this. I just want to see if this works. Ah, okay. Yeah, okay. So it just doesn't do what I want to do. I was hoping I could do something nice like that, but it doesn't. Does it work with lists, I wonder? I suspect it'll do the same thing. It'll just concatenate them. Or join them, I'm not sure. Yeah, so I can add them, but what I want to do is I wanted to create a new tuple. I wanted to create a new tuple that adds the individual elements. But it's fine. If that's awkward to do, then there's better. That's I don't need to do that. I was just hoping it'd be easy to do that, and then that'll be a nice solution. A zip map. What is that? Zip map. Okay, so I know what map function does. What does zip do? Finds elements for two lists while with matching indices to each other. I'm confused. What does this do? So let's say we have okay. Can I do this? No. Okay, fair enough. I just want to see what this does, though. -1. Sorry, 1 minus 1. 0. Yeah, okay. I get that it's possible, but actually, this just makes it more awkward for what I wanted to do anyway. So I won't do it that way. What was I trying to do? See, this is the problem. I'm going so deep into things, finding ways of doing things that I forget what I was trying to do originally. What I was trying to do originally was... Right, so now that I have the next direction is I want to move in the right direction. That's what I wanted to do. And so basically I just need to do... can I do a switch on a string in Python? Is that even a thing? Switch? String? Can I do that? It doesn't seem... Oh, I can? Well... No. This doesn't seem like... No, I don't want to do... Oh, you said match. match case. Okay, let's try this. So, do not want to sign up. So match. Match what again? I'm matching next direction. So case that it's north. What I want to do is current equal to maze. So if it is north, I want to do current -1 -1 and current 0. I really just hate having to use this, so I'm just gonna say x is equal to current 0. It's just making it very confusing for me. And y is equal to current 1. So I know this is unnecessary, but it's just making it really confusing for me to look at. X. There we go. Case we are, so yeah, okay, we have all cases. So if it's south, want to do maze +1. It is east, we want to do x +1. It is west, do x -1. And this all needs to go in here, sorry. Like so. And is that it? So now what I do, finally. Oh, okay, that's nice. We'll do that. Cute. There. Yeah, so I only learned I think it was yesterday that I learned about that kind of like star thing that you can do with a list. Like you showed in that example there with map and zip. I think I used it in my day 8. Yeah, I didn't know this was a thing. Took me a while to kind of figure out how to. I was trying to do this but couldn't quite figure out how to do it. But yeah, that's cool. So interesting. Anyway, that's not what we were doing. No, 10A. That's what we're doing. Is this it? Okay, so now, if this worked, so if we went east, then we can do we can follow path. Well, I suppose this should return steps rather than print it. Return steps. And so this should print follow path. And it's gonna go from here. And the from direction would be this, right? That makes sense. So we've gone east. The from direction doesn't matter initially, does it? No, it does, yeah. And likewise, depth value error, then we try this one. Now we do the same thing, but we go... sorry, we go west, so we've come from the east. Now, if it isn't east or west, then let's do it with north. Because that one has to be true then. So... this -1, and that means we've come from the south. Sorry, we don't need to call where to next. Just go like this. So -1. That means we're going north. We've come from the south. Oh. Match next to invalid syntax. syntax. 'Cause, 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 'cause Is it? Why is it invalid syntax? Well, do you know what? That's a great question. I don't actually know because I'm running this through Sublime and I'm not sure what exactly it is doing. I think I have 3.9. Is that something newer than 3.9? You said it might be. If not, I'll just replace it with an if else if I'm not gonna bother installing something new. Yeah, okay. That's fine, no worries. We'll just do if then. If elif. So if let's write it down here. So if hey Oliver, sorry, I missed your greeting. Don't know if you're still here. Anyway. So if what was I doing? If nextdir is equal to n this elif and so on. Well, I might just okay. Error. Ah, okay. Interesting. Okay, so if actions at current, okay, we didn't get anything. That's fine. So hang on. So what do I need to do? So this is because when I do s, when I'm trying to find s, I can find full stops and other things. So that's important. So suppose all I need to do here is return value error for this. Yeah, we can just do that. If I suppose it feels like cheating here, but anyway, if current is equal to a full stop, well then it's raise value error, and this will be ground. Oh, okay. During handling of the above exception, another exception occurred. Oh yes, those pesky new lines. Where can I get rid of them? Well, probably here. Base is file that read lines. Hello. Well, I started day 10 about an hour ago, maybe. Actually, it doesn't feel like that long, to be honest. But yeah, so we finished day 9. I had to go for 40 minutes or so. I had to do something, and then we finished part 2 of day 9 in like 5 minutes. That was fairly straightforward, and we've been doing day 10 since. So we probably started about an hour ago. We started day 10. And Steve has been helping me massively here. So, okay, so we're getting the Why are we getting a new line error when we're looking for S? We shouldn't be getting a new line when we're looking for S. Let me just print out. Hang on, okay. It's current process 0, 0. Right. Let's. Oh dear. Sorry. There we go. Okay. Don't need to print it out anymore. Okay, so what happened now? No, I know this looks really stupid, but it is actually correct. So what I'm doing is I'm trying going east. If this doesn't work out, so if we get an exception, we then try going west. If that doesn't work out, we then go south, and that should always work out. If these two accepted, if these two through or raised errors, then this one then this one should work always. Okay, so what happened here? Index out of range. Here, index out of range. So we tried going east. How is that an index out of range? That should be no problem. Ah, it's not here. Sorry, it's here. I was just about to say that. There's no way. Follow path. Where am I using current anywhere else? Just the actual. No. Okay. This gave me a mate's gonna be an empty list. I feel like something here's not quite right. Print mates and print starts, I think. Ah, so start doesn't seem to be working. Hang on, print start. Why is start a minus? Okay. That's not right. Sorry, no, that is right. Sorry. I don't want to pass in that. I actually just want to pass in the current position. Okay, that's actually easier. Well, no, it isn't actually. Well, sorry, it is. It is. But I want to do this slightly differently. Current pause 1, comma, current pause 0, plus 1. Right. I want to do the same thing here, but minus 1. Whoops. And the same thing here, but minus 1 on here. Okay. So what's next? This is fun. We printed out start. Where else are we printing stuff? Well, sorry, I won't do a message here. So I'm a bit confused as to why. Because okay. Because it's the where to next function. So it didn't fail here, it failed here. So that's what happened. And so that's why I tried to go through the other way. But yeah. It shouldn't have done that. Okay, but that's okay. What I need to figure out is why it's failing here then. So the follow path function, somewhere it's going wrong. So as well as printing out start, I want to print out current. Okay, so it failed pretty much instantly, which is interesting. I'm pretty sure, right? Well, actually, let's print it out here. Up here, I should say. So we started at 1, 2, which is correct. Where to next? With the pipe from direction. Okay, so starting east should have worked. It should have worked. So I think I'm mixing up my X and Y somewhere. Because starting east should have worked here. And it hasn't. Well, I think I need to go backwards here. Okay, that's better. So starting east, we've gotten this. Okay, and then I think it moved in the wrong direction here as well. Because it should have said east then. So I got these the wrong way around as well. I didn't think I had. Am I meant to say, I think this might need to be the other way around. God, this is going very well, isn't it? Back here for a second. So it's starting. Yeah, I don't think I need to print this anymore. So we're starting east. That's the first one. starting east. This one, and we'd come from the west. So why is this so? Okay, well then I do want to print this again. So why is this not working? Current and from. I want to print both of it. Okay. So this worked. So it's starting east. We're starting at 1, 2. Yeah, I think that's wrong. But anyway, it doesn't matter. It's fine. So we're starting at 1, 2, which is actually 2, 1. And we've landed here. We've come from the west, and when we call where to next, that's being confirmed. Then why is it printing out dot? Where have we found a dot going from the east? That's what's really weird here. Yes, something's going wrong here. So something here is going wrong. So I'm not sure where where is it printing this? So found next runs. Yeah, go for it. What's up? I mean, the problem with that, it sounds like a good idea, but the problem is I just don't have any sort of set availability. So I couldn't kind of say, okay, let's do tomorrow at 3 because I have no idea if I'll be free tomorrow at 3. So it'd have to be a very, very sort of last minute thing. Okay. Let's get back to this. Sorry, why is this not working? So I'm very interested as to where this is coming from. Yeah, yeah, I'm technically on holidays. I mean, well, it's not that I'm on holidays. I just not in, I'm not in college, nor do I have a job currently, really. I have, yeah. So I'm not really doing anything, but I have a lot of things going on during my day to day, and especially these next couple of weeks. So I just don't know. I didn't know if I'd be free today to stream or not, and in the end I was. But actually, I had to stop halfway through, so I wasn't actually as free as I thought I was. That's the problem that I have at the moment. That's really a problem I've always had. I can't really set any kind of stream schedule because I just never know when I'm free. Okay, it prints out found next. And actually, let's print out next direction then as well. So found next. Okay, so let's go through this. So we're here. We've come from the west. Found next east. Should now be here. But it doesn't actually do that. 940. Yeah. It doesn't like this, which is interesting. What was I trying to do here? I'm lost now in all my variable names is the problem. I'm confused as to what everything is at this stage. Yeah, maze is just the list, or maze is the entire, the list of strings. Current. And current is a position, wasn't it? So if I go print current, that's just a position, isn't it? Found next. Ah, yeah, see, current isn't. But I think this is meant to be... So, okay. So once again, I actually need a current position as well as... well, no, so I don't necessarily need a current position. Sorry, I don't necessarily need a current thing. But I suppose it's you. Right, so we're using start here. Okay. Let's call this current pause. This is much better. Okay. I think this is much promising. Much more promising, I should say. Yeah, see a cosec sec cot. I'm just gonna call you trigonometry guy. Cosec sec. Okay, so we started here. We went east, so starting east. So we are now at 1, 2, whatever. Which is here. And we came from the west. Found next, which is east. We're printing out current. That's fine. Then we moved, and we have 7W. And next is south, correct. And there we went wrong. Down next is south. Moved, and it didn't move south. Because what I haven't done is I haven't updated... well, that doesn't actually matter, does it? No, it does, yes. I haven't updated current position. Okay. So we're doing this slightly different. Current pos is equal to what way am I doing this? I'm sorry, I could just say y. Okay, there we go. I can just do it this way. This is y plus 1. This is x plus 1. X minus 1. And finally, current, well, I can get this basically. Well, do you know what? Actually, slightly better than this. I'm going to change this ones again. Is say y equals y minus 1. Y equals y plus 1. X equals x plus 1. X equals x minus 1. And now current position is equal to the new yx. And then we can do this. And that worked. It took far longer than it should have. Oh god. But it did work. Getting rid of all of my unnecessary prints. There's still one somewhere. That one. So it took 8 steps. But obviously the answer isn't 8, it is 4. Right, so in the first one, it is 4. So the answer well, total steps, or I suppose this is path length, is equal to 0 initially, let's just say. And then all we'll do is we'll set path length equal to this, rather than the print. Like so, like so. And then at the very end, our answer should be our path length divided by 2. And we should print out our answer. Now I'm interested to see what happens now when... Yeah, so interesting that it's done it like that. Okay, whatever. I think I can clean this up even more. I don't think... Do I need current? Yes, I do. Yeah, I suppose I do. Okay, that's fine. Actually, no, I can't clean this up slightly. But I can do this up here. And then we don't need this anymore. This still works. Okay, great. That's slightly nicer. And I will call this start. Okay. Okay, that worked. So I just want to try out a few different ones then. Here's a more complex loop again. This one is apparently 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that's correct. Okay. I think that's it. So I think all I need to do now then is we don't need this, so I might, well, let's just let's maybe delete this file. But what I need is a new file. And this is going to be our full input, which is all of this. We're going to save this as input. Like so. And now I should be able to just open input here. And the answer we got, 6,701. That's the right answer. Whew. Okay. Alright, that was... when I read through it, I remember thinking, okay, this is fairly simple. This is fairly straightforward. Like, the actual thinking part wasn't that difficult. But the execution just... I got bogged down in it quite a few times. Quite like, yeah, I'm quite exhausted, to be honest, but I really want to finish it now. So let's see. Let's go for part 2. I really want to finish it, and let's see what happens. I'm not liking this already. You quickly reach the farthest point of the loop, but the animal never emerges. Maybe its nest is within the area enclosed by the loop. To determine whether it's even worth taking the time to search for such a nest, you should calculate how many tiles are contained within the loop. Oh god. The above loop encloses merely 4 tiles. Does it? Above loop encloses merely 4 tiles. Oh, I see. The 2 pairs of grounds in the southwest and southeast marked. Not in the loop. Here's the same loop again with those regions marked. In fact, there doesn't even need to be a full tile path to the outside. 4 tiles. Sorry, in fact, there doesn't even need to be a full tile path to the outside. 4 tiles to count as outside the loop. Squeezing between tiles is also allowed. I see. So how will I do this? So I'm reading through this, and to be honest, this is the first one I've read where I really have no idea where to even start. How do I determine... whether it's inside the loop. Okay, so my first idea, my first idea. God, I think I might actually leave this till to another time because it's. I think I need to think about this a little bit more, and I am quite exhausted, to be honest. I'm not in a particularly thinking mood, but what I'm thinking of here is every time we turn somewhere. We turn, so if we've let's say, okay, let's do it this way. So let's say we're going here. Once we turn right, I think it's safe to say all of these are now outside. So then we keep going straight, we turn right again, we can say all of these are outside. And likewise, we would say that all of these are inside. So now we turn right again. All of these are outside, all of these are inside. Turn right again. All of these are outside, all of these are inside, and so on. And I think we do that all the way around. How does it work when we get here? So when we turn left, this becomes outside. This becomes inside. But now when we turn right here, this becomes outside. Sorry. Other way around. Sorry, so this is outside. This is outside. This is all outside. When we turn right... Oh, this is tough. I know that I can do this. But I also know that right now, I am too tired and a little bit too burnt out to be able to figure this out. Which is a little bit sad, actually. But yeah, this is a hard one. I was expecting part 2 to be a lot simpler, to be honest. I don't know exactly what I was expecting, but I was expecting it to be a lot simpler. But damn, 10 part 2 is a tough one, I think. Now there might be a better way of doing this. So that was just the first. That was just the first kind of idea that came to my mind there about how we might go about this. There's very likely better ways of doing it. Because obviously something else I was thinking of was, you know, we could find kind of the box that bounds or bounds, whatever. The bounding box inside of which our entire loop falls into. But then what? So we could figure out that all of these are in some way inside, but then we'd need some way of figuring out that these aren't actually inside. Hmm. Yeah, so here's another example then. So our start is there. Hmm. Okay. So I think this is a good place to stop for today, mainly because I'm not sure how to go on from here. And as I said, I'm just too tired to try and figure it out now. I might come back to this later. Maybe on stream, maybe not. But yeah, I will come back to this later at some stage. This is definitely the hardest one I've seen so far. I'd like to look at the, if I just look at the leaderboard actually, or not the leaderboard, the stats. Yeah, I don't know, it's surprising to me. I don't know. I was just expecting a lot more people to have figured out. Well, I suppose if you look at the change sort of from day 5 to day 9, the numbers have been pretty much the same. Obviously, day 6 was quite easy. I remember day 6 was quite easy. But other than that, you know, there isn't really a huge jump, right, between day 5 and 9. There was a big jump between day 4 and 5. Day 5 was definitely harder. Now, I think day 6, 7, 8, and 9 weren't all that hard. I think 5 is still one of the harder ones. But I think once people realize I can't do 5, they don't even bother trying 6, if that makes sense. So generally, I'd expect numbers to go down, even if they aren't necessarily in order of is the hardest. But already you can see a fairly sharp decline there between 9 and 10. And actually, you can see with 9. 9 was the one that was super easy to go from part 1 to part 2, and you can see only 900 people didn't, you know, out of 66,000 people, only 900 didn't go on to do the second part. If they finished the first, they did the second one, you know, straight away. Whereas with part 10, that number is a lot more substantial. So, just something to kind of think about, I suppose. Anyway, yeah, like I said, I think I will leave it here for today. So, I will come back to this. I will hopefully think of a solution. And if not, you know, I'm not opposed to seeing what other people did to solve this. I don't care for looking at the specific code. I'm just more interested in what exactly is the algorithm here. But that's fine. I will try and come up with a solution at some stage. I will try and think a little bit harder. And other than the solution I came up with there a few minutes ago, which I'm not sure is really all that doable. But anyway, we'll leave it there. I'm quite tired. I want to go have some food, have a drink, and I'll be back at some stage, hopefully. Thank you again for joining me. Thanks for helping out. There was a few people, again, helping out in chat today. It's quite nice that people are willing to watch someone struggle with Python really, really hard and help them out. So so thank you very much for sticking around, for having a look at this with me. I would encourage you to do these for yourself. If you're watching this and you haven't done these challenges before, try them out. I'm having lots of fun doing them. I really am. So I would encourage you to try it out for yourself, because they are quite fun. We're almost halfway. We're day 10. There's only 25, so only a few more challenges where to go. But yeah, we'll leave it there, and I'll come back to this at some other time. But thanks again for watching. Yeah, exactly. It wouldn't be fun if it was super easy. You're right about that. It's struggling is what makes it fun. Getting the solution, getting the answer right after you've spent an hour and a half trying to figure out why it wasn't right earlier is very satisfying. So we'll leave it there. Thanks for watching, and hopefully see you again soon. And I'll find someone to raid again now.